Assalamualaikum. For this video, we will discuss about mailbox. Before we start, let me introduce our group members, which is myself, Nurin Zuliana, Izatul Aina, Nurdini, and Bushra Hanan.
Mailbox gained popularity on online platform. It is among the greatest choice for people with hectic schedule or little time to cook. This novel method of food preparation are always chosen first. Mailbox, on the other hand, are considered as sustainable and substitute for traditional food retailing, and have potential to boost sales of eco-friendly goods, cut down on food waste, or encourage vegetarianism. Also, not only simple, it also tastes good and increase hunger. There are competition in mailbox industry. The first thing is diverse offering. It is used to extend beyond traditional meal kits with mailbox by specialized options to customer. Empathize particular cuisines by giving instruction or only limited ingredients. For the second is quality and freshness. Quality and freshness of the ingredient are always play big part of the mailbox. People are more into freshness and quality ingredients. High quality and organic ingredients become main attraction due to health benefit towards consumer. The third one is convenience and packaging. Packaging are the key to attract people because it is the first thing people see before buying products. Eco-friendly and sustainable packaging are the first thing people search in nowadays due to people's concern about our Mother Earth.
As we know, the key need to use mailbox is student, mother, and worker. Based on our experience, as a student, we need to learn how to adapt on the different living style. Bring a mailbox is a must for student, but the problem is to keeping the food stay hot. The food get warm easily because object at a high temperature release heat that travel from it to object at a lower temperature. Is it not nicer to eat the food as how it should be rather than it be warm? For instance, buying a soup noodle for lunch, however it get cold after 30 minutes. To solve this problem, students need use an electric mailbox that can be found in a direct shop or an online shop. Electric mailbox are used to keep our food hot by switch on the button and start heating the meal. Students do not have to worry about the food getting cold or warm. The big problem in unwanted cost is the mailbox has a high capacity. Even a large quantity of food appear to be a small quantity and may unintentionally overpack your lunch and waste food. Second, hard to clean because some part is dishwasher safe and some part of it is not, and pricey. What will happen if the need not meet? Firstly, the taste of food will not feel better as before when food become cold. Second, will increasing waste in the world. Lastly, food easily gets spoiled and can cause food poisoning.
Thermal energy get transferred. It has three ways. First, conduction. Second, convection, and the last one is radiation. Conduction involves the transfer of heat through direct contact between particles in a material, and convection is transfer of heat through the movement of liquid or gas particles, and radiation is the transfer of energy through electromagnetic waves such as heat from the sun reaching the earth. Conduction is process of heat transfer within a material or between different materials in direct contact. It occurs through the vibration and collision of neighboring atoms or molecules. In conductive heat transfer, first, material method. Conductive depend on the material. Metals are generally good conductors due to their free moving electrons, while insulators like wood or rubber are poor conductors. Second, temperature gradient. Heat flows from areas of high temperature to lower temperature. The steeper the temperature difference, the higher the rate conduction. And the third is length and area. The thickness of the material and the cross-sectional area through which heat is flowing influence conduction. Thicker materials and larger cross-sectional areas reduce the rate of heat transfer. 4. Thermal conductivity. Each material has a thermal conductivity value that quantifies its ability to conduct heat. Metals typically have higher thermal conductivity than non-metals. For example, if you touch a metal spoon in hot soup, the heat from soup conducts through the spoon and reaches your hand. Convection. Convection is the process of heat transfer through the movement of fluids, liquid or gases. It involves the bulk movement of the fluid itself, carrying heat from one place to another. Here are key aspects of convection. First, natural and forced convection. Natural convection occurs. The fluid movement is caused by temperature difference, leading to buoyancy force. Forced convection involves external means, like a fan or pump, to move the fluid. Second, fluid circulation. In a fluid, warmer portions tend to rise as they become less dense, while cooler portions sink. This creates a continuous circulation pattern, transferring heat along with the fluid movement. Third, application. Convection is commonly observed in everyday situations, such as the rising of warm air above a heater or the circulation of water in the boiling pot. It also plays a crucial role in atmospheric and oceanic circulation. And the fourth is transfer rate. The rate of heat transfer through convection depends on the factors like fluid velocity, temperature difference, and the physical properties of the fluid. Understanding convection is essential for various engineering applications, including the design of heating and cooling systems. Radiation. Radiation is the process of heat transfer through electromagnetic waves. Unlike conduction and convection, radiation doesn't require a material medium to transfer heat. Here are some key points about radiation. First, electromagnetic wave. Heat is transferred in the form of electromagnetic waves, such as infrared radiation. This wave can travel through a vacuum, making radiation possible in the space or through transparent medium. Second, speed of light. Electromagnetic waves travel at the speed of light. This makes radiation a relative fast method of heat transfer. Third is emissivity, the ability of a surface to emit and absorb radiation is characterized by its emissivity. Dark, rough surfaces generally have higher emissivity and are better at radiating heat. Fourth, examples, the heat from the sun reaching the earth is a primary example of radiation. Similarly, objects like a hot stove or light bulb radiate heat through the infrared radiation. 5. Inverse square law. The intensity of radiation decreases with distance from the source. Following the inverse square law, this means that doubling the distance from radiation source reduces the received intensity to 1/4. Radiation is vital in various fields, from space exploration to the design of energy-efficient buildings and the electronic devices. So this is our approach. We make double side of Tupperware because we want to save the space. So we think about making a lid with temperature light indicators, so we easy to know what temperature is our food right now. So you can see right there is space to fit the lid of the container. Some of container they don't make a space, so the gravy and the fruits will mix. So you can see we use silicone material for the holder, so it will not easy to slip. For the inner part, we use stainless steel, which is rust proof. And in the middle, we will save for the vacuum insulation, and the outer layer we use copper, and the last layer is made paint, so it will comfortable to hold. So we use magnet to combine the parts, so it will not leak at all. How does copper insulation work to keep your drink the perfect temperature? Copper's superior heat and cool retention properties mean that the metal actually responds to the temperature of the drink contained inside, holding it steady for longer. This fascinating superpower of copper stabilizes thermal loss in the insulated cups. That's why it truly helps maintain your drink at the same temperature as when it went in. We are talking about hotter coffee and perfectly chilled cool drink all day long. But how exactly does the copper insulating process work? And is there any real science to back up these heat retention claims? Heat conduction occurs due to the law of thermodynamics. How does the bees benefit from copper lining? Because of this natural temperature conduction phenomenon, copper layers are incorporated into the inner portion of tumbler lining. The conducting copper layer is sandwiched within the void of double-wall vacuum insulation. This provides a 1-2 punch of heat and cool retention. It goes toward drawing any heat toward it, which works in two ways to retain both ends of the temperature spectrum. First, keeping cool drink chilled. As the no warmth from the atmosphere is drawn in and trapped inside the copper layer that sandwiches between the double walls. This prevents any heat from your outside world from making contact with the stainless steel interior that the liquid touches. Your ice won't melt and your drink will stay perfectly chilled. Second, keeping hot drink toasty. Radiant heat from your hot beverage is attracted to the copper layer on the inside of the double walls. The copper warms up and keeping your drink wrapped in the cocoon of cozy warmth. This trapped heat can't escape to the outermost layer where it can eventually bleed away into the environment, which would gradually decrease the temperature of your beverage. Physics of mailbox have four. First, conduction. Conduction. The inner chamber of a thermos is often made of material with low thermal conductivity, reducing heat transfer through direct contact. This helps to keep the contents at a consistent temperature. Second is convection. The vacuum or space between the inner and outer walls of the thermos eliminates air, reducing convective heat transfer. Without air, there is less opportunity for heat to be carried away by fluid circulation. And the third one is radiation. The reflective surface on the inner walls of the thermos minimize the radiative heat transfer. This involves using materials with low emissivity to reflect heat back into the content rather than allowing it to escape. And the last one is vacuum insulation. Many thermos incorporate a vacuum or a layer low conductance gas between the inner and outer walls. Vacuum are excellent insulator because they lack particles that can conduct heat.
There are many benefits that you will get in our product. First of all, our product very affordable with high performance. It also available in cool and various color to suit your style. Lastly, our product is very easy to clean and designed for easy to bring anywhere. In conclusion, our mailbox, infused with the principle of physics, stand as a testament to culinary innovation with a focus of enhancing efficiency and adaptability, especially for mothers, workers, and students. Our approach aims to redefine the mailbox experience, making it accessible and convenient to users of all ages.
That's all from us. Thank you.